Let's just say it's a good day for the unemployed. You might need a little bit of context for how I came up with this idea.
For a brand that only produces a few thousand watches a year, Moser sure know how to court controversy. This was particularly clear in 2016 when they announced a new release that was in response to the Apple Watch that was launched the year before. Named the Swiss Alp Watch, it was a bold statement about what Moser saw as the lack of meaningful response by the rest of the Swiss watch industry.
I like watches. I've got a couple of them. And obviously, I like talking to people about watches. Enter my coach Simon, who was showing me this watch that looked like an Apple Watch. And I don't know why, but I said I could make that. Now, a little background. I want to be a watchmaker. I think that's pretty sick. I've put together a couple watches, but I've never made any individual components from scratch before this project. I wasn't even sure that I'd be able to actually manufacture anything on my own. But trust me, I have a plan that will put this Moser Swiss Alp watch to shame. Also, if you're a watchmaker or a watchmaking school, surely this helps with something. Alright, I'm gonna create this watch perfectly. And obviously, nothing's gonna go wrong. Alright, here's the problem. The crown position on most watches and most movements is located here, at 3 o'clock. However, because Apple wanted to be special, they've located the crown here, in an offset position. This means that the stem and the crown of my watch movement don't line up. This means that I will have to create a mechanism that will allow me to change the time on the Apple Watch. Unfortunately, I don't have the money, time, or experience required to create a dedicated movement for this project. You know, I could give you all the details on how I'm going to make this watch, but I won't. Psych! Just have a look at this beautiful 3D model. I'm not one to toot my own horn, but I think that's worth something. So check it out. I'm going to link the stem to the Apple Watch's button, allowing the watch to be put into time setting mode. And then a pulley will transfer rotational force from the crown to the stem. This is definitely not the best solution, but you know, I couldn't really come up with anything better. How am I going to make any of this? This guy right here. What a guy. He's great. He helped me a lot with this project. And he makes watch dials out of silicone or unused computer chips. Anyways, skipping a bunch of the boring stuff, I got these bad boys. Some of the first watch components that I've ever designed from scratch and then got them produced. After attaching dial feet, I could finally put something together. That makes me feel something. This is my brother. He's a knife maker, so he knows how to make things out of metal. But better than that, he also knows other people who make things out of metal. I'm shocked. Because of this, we went on an adventure to the Canberra Knife Show, where I met this guy, Corin, from Nearrock Tools. He creates high quality tools focused specifically for knife making. And he's agreed to help me manufacture some of my components. Now that I had access to equipment that would allow me to manufacture components out of metal, I was going to make the most out of it. Instead of conducting experiments that wouldn't have any real purpose outside of work for this project, I decided to manufacture a normal watch. This would allow me to practice and experiment with techniques and processes that I might want to implement into the Apple Watch. It also helps me justify the amount of money that I've spent on this project. This was awesome. We did things with these machines that I didn't even think was possible. Firstly, obviously, the laser cutting and engraving went great. It was my first time doing anything like this with metal, and it turned out great. Just have a look at that. Cutting my other materials also went well, with the only possible difficulty being the titanium Damascus. However, changing the settings of the laser engraver cut through it. Now, here in my opinion is the coolest bit. I'm not exactly sure how it works, but by changing the speed and the frequency of the laser, it's possible to change the color of brass, and this is what we got. That's not paint, but honestly, this is so insane to me. Also, I do need to highlight this is only possible with a Mobot fiber laser, and Corin has a much more detailed video on how this works. These are some of the finishing techniques that I didn't end up implementing in my project that I did use for my experiments. I'll definitely consider implementing them in the next iterations of this project, but that would be after HSC is finished. Now that all the side quests are finished, it's time to work on my mechanism. I initially used CAD to see if my linkage design would actually fit. Then I cut out and bent a version out of brass that would be more durable. This allowed me to get the precise measurements that I required and allowed me to drill the holes, which worked perfectly. It didn't work perfectly. Fortunately for me, that design also didn't work. So now I've opted for a far simpler, straight design that uses the base measurements from my last failure. There is a very lucky coincidence in this project, which is where the Apple Watch button uses M.9 threads, which are the same threads that are used on watch crowns, extenders, and watch stems. So this is how I attached the linkage system to the Apple Watch button. First, I tried to manufacture this pulley wheel on a drill press. This was probably not a great idea and was not suited for the task, but luckily at school, we still have some metalwork lathes from when they used to teach metalwork. So I used that to manufacture my pulley wheel, and that works perfectly. To actually thread the pulley wheel, I used a broken crown stem, which I sharpened, and then just used that to thread the pulley and my other components. Now it was time to actually put the thing together. I made some very, very small brass rings that allowed for correct spacing of my mechanism, and then I just threaded on the pulley wheel, which I then cemented in place with adhesive. Then I just attached the O-ring, and this was the first time that my mechanism was working, and I was quite excited about that. I decided to use Damascus steel for my final dial choice. The finishing of this was pretty much like finishing a Damascus steel knife. So first it was sanded to a very high grit, and then it was dipped in hydrochloric acid, or we used Gatapiss because it gave us a much darker contrast. Then the only thing that I did differently was I demagnetized it, obviously, and I coated it in clear enamel so the steel wouldn't rust. This is probably the coolest thing I've ever made, and actually being able to wear it is such an incredible feeling. Now, the mechanism doesn't work the greatest right now. The O-ring slips a little bit, but that would be an improvement for the future when I make the next iteration of this project. This project turned out far better than I imagined, and here's what some people have said about it.
Look at it, chic, minimalistic. The black really goes in with the I would say, ties into the watch look. Overall, high quality project, lots of practical skills, really nice finishing skills, everything high quality. I think it's a very, very high quality product.